Hello InfoPerson, this is Anton, and it's about time we've discussed Mars once again. But, as I like doing with these Mars videos, let's once again start this one with a bunch of strange rocks discovered on the Martian surface. And here's the first one. A very strange triangular pyramid that was discovered on the Martian surface not so long ago. And this one is referred to as Candor tetrahedron, which naturally gained a lot of attention because it resembles some kind of an artificial structure. And though originally this was identified back in 2002, it recently resurfaced on social media, mostly because once again people started claiming that this is signs of alien life. But based on a lot of high-resolution photography, geologists are now pretty certain this is a typical positive relief knob, or basically a remnant of more durable rock that was eroded by Martian wind for billions of years. And though by itself it does resemble a pyramid, when looking at this in the context of other objects, this whole landscape contains a lot of lumpy, uneven, and even perfect geometric constructions that essentially tell us about complexity of Martian erosion that's been happening here for a very long time. But this is far from the only strange rock discovered, because right here we actually have something else really strange. So if you were to zoom in on this location, you would actually see something like this that was recently captured by Curiosity. And while here, these dragon scales, or these honeycomb shapes, have also recently captured imagination because of their unusual appearance. But we're pretty certain that this is not a dead Martian dragon, because we do have very similar formations on Earth. And on Earth, these patterns are very often formed by repeated cycles of saturation and drying, or sometimes freezing and thawing. And they normally resemble something like this. And so something very similar is happening here on Mars. Would this be a result of some kind of a wet-dry cycle, and actually providing us significant clues about Martian environmental history? As a matter of fact, here, this is a really important evidence that Mars definitely experienced some kind of an unusual wet-dry cycle, instead of just being consistently dry. But at the moment it's not entirely clear how exactly this formed. Okay, let's move on, because in the last few months there have been some really exciting discoveries in regards to geology, atmosphere, and a few anomalies on Mars, which means that we're going to be tackling quite a lot in this video, with quite a few of these landmark discoveries actually solving a lot of mysteries about Mars, especially about why Mars is the way it is. And let's, I guess, start with some of the very strange anomalies. The first one is super bizarre. This is known as the Shadow of Utopia Planitia, a massive crater plane that seems to contain a strange anomaly that's kind of difficult to explain. And you can see this anomaly in this image. Ever since 1976 and the initial observations, this location had this very strange shadow that has now expanded by approximately 300 kilometers. And actually has been expanding at least 6 kilometers per year. And while nobody is entirely clear why or what this is. And actually nobody even knows why this location and why nowhere else. And so in the last 50 years, this bizarre location dramatically transformed in front of our eyes. But this is not a true shadow, and instead seems to be a patch of dark volcanic material that has been slowly spreading on the ground and moving in the windward direction. As a matter of fact, based on the observations, it seems to be a mineral enriched in olivine and pyroxene, and seems to represent leftovers from ancient volcanic eruptions. Eruptions from millions of years ago. But based on the images captured by ESA's Mars Express, and based on the comparison with the NASA's Viking orbiters, it looks like something has been distributing these minerals across the surface, and doing so consistently for at least 50 years. And right now we have two potential explanations, although I guess maybe three if you want to consider aliens, but probably not aliens. First, this is probably some kind of a wind distribution. Because Martian winds can be pretty powerful, they can pick up volcanic ash and then deposit it in other areas. And so this is basically the result of a lot of ash and dust being spread in different locations every time there's a massive windstorm. Second, this might be the result of surface clearing, or basically there was dark volcanic ash underneath, but it was buried beneath a layer of much lighter dust. And the wind is now stripping everything away, uncovering the darkness that's been hiding under it. Either way though, whatever this is, it is still a little bit mysterious and definitely resembles nothing we've seen before, and well, honestly looks a little bit scary. but chances are in the next few years we'll know exactly what this is and how this works. Just not yet. Okay, apart from this anomaly, there are also some really important discoveries in terms of astrobiology. And specifically, NASA's Curiosity and Perseverance rovers have now officially identified an extremely diverse amount of molecules, organic molecules, that has never been seen on Mars before. And so, for example, in a landmark experiment using Curiosity rover, researchers used a chemical to break down some of the rocks in the samples collected from the Gale crater and managed to uncover more than 20 organic molecules, including nitrogen heterocycles, which are generally believed to be precursors to DNA and RNA. And obviously this is not signs of life itself. It does prove that building blocks of life seem to be present here and have been preserved here for over 3 billion years. In contrast, the Perseverance rover, that's almost 5,000 kilometers away from this location, discovered this very strange rock feature referred to as Shiyaba Falls. We've actually discussed this in a lot of detail in one of the previous videos, but in a nutshell, here inside this mudstone, scientists uncovered unusual spots resembling very small, dark-rimmed blobs that seem to contain vivianite and greigite. And while normally on Earth, these very specific mineral patterns are very often associated with microbes that obtain their energy through chemical reactions inside wet sediments. In other words, when we see this on Earth, we know this came from bacteria, but it's not clear what happened on Mars. At the moment, it's been several months, but there has not been any updates about this yet, so we're still not sure what created this. But the presence of these minerals alongside macromolecular carbon does make a very compelling argument that this might be a potential biosignature, although obviously we still have not found actual signs and actual fossils. Technically, these could still be results of non-biological chemical reactions. But there have been some other geological discoveries that are also just as exciting. For example, one of the locations contained quite a lot of nickel and iron sulfide, which is once again usually associated with life on our own planet. But apart from this, scientists also discovered a mineral referred to as Garnet. A mineral that technically should not be on Mars at all. Now technically this was actually found inside a Martian meteorite, but we know that this meteorite definitely came from Mars. And while on Earth, garnet usually forms under extreme heat and pressure conditions, very often because of plate tectonics. But Mars does not have plate tectonics, so it should not exist on the planet. Which means that Mars might have had some other geology we do not understand, or maybe it was caused by a massive meteorite impact and some kind of an ancient magma flow that somehow produced extremely similar conditions to what we usually find on planet Earth. But this also potentially suggests that maybe Mars also experienced very similar geological processes billions of years ago. Or maybe this garnet came from somewhere else entirely. So essentially here we have a new geological mystery and something that suggests Mars was definitely a lot more complex back in the days. Maybe even containing geological conditions resembling plate tectonics. Then we had some really intriguing discoveries in regards to the Martian atmosphere, and specifically explanations for why Mars is losing so much atmosphere and why the pressure on the surface is so low. And this was actually observed by the Maven orbiter, whose mission was to figure out what happened to the Martian atmosphere. And so here in 2025, it detected the effect referred to as Swan-Wolf effect, a phenomenon you see illustrated right here that involves charged particles from the Sun squeezing the planet's atmosphere in a very similar way to how you squeeze toothpaste from a toothpaste tube. And we've actually seen this happening in the Earth's magnetosphere, but this is the first time ever we've seen this deep within a planetary atmosphere in real time. And it only became visible because of a massive solar storm, which amplified this effect. And while in essence this tells us exactly how Martian atmosphere seems to be lost, and how the solar activity is extremely efficient at stripping it over time, while at the same time showing us how the Martian ionosphere seems to be completely reshaped by these effects in much more powerful ways than we expected. Naturally, something very similar very likely happens on a lot of exoplanets that do not contain powerful magnetospheres. Then we had some really intriguing discoveries in regards to the Martian ozone layer. And here scientists actually discovered that Mars seems to be able to create its own seasonal ozone layer inside the very cold North Polar Vortex where the temperatures drop to as low as minus 40 degrees Celsius, minus 40 degrees Fahrenheit. The temperatures where the water vapor starts to freeze. And since usually water vapor destroys the ozone layer, here its absence allows the ozone to build up in the darkness of the Martian winter. Which means that at least in certain locations on Mars, some places are actually protected from Martian radiation by a relatively thin but still present ozone layer, and even possibly a permanent ozone layer that protects the surface from deadly radiation, meaning that we might have some locations on Mars that are slightly better for human habitation, but exactly how thick it is still unknown. Then we have some more discoveries in regards to the ubiquitous Martian dust devils, or these tiny tornadoes that seem to be all over the place. As a matter of fact, they do appear quite often, and at least one of them even passed extremely close to the Martian InSight mission a few years back. And well, here in this new study, researchers wanted to map them and to basically figure out how fast they're moving and how frequently they appear, which is where we get this map. And so here, by using 20 years of imagery, researchers tracked 1,039 dust devils moving across the surface of Mars, with the study discovering that overall, the wind speeds in this case seem to be much higher than predicted by previous models, with the fastest dust devils recorded moving at approximately 160 km per hour or 100 miles per hour, or more than double the highest value previously recorded by the surface missions. In other words, they seem to be faster and more powerful than we initially thought, while also solving a kind of a sand transport puzzle, where the scientists struggle to explain how sand dunes on Mars shift and how dust remains airborne for months at a time. Something that you can kind of see in this image during a typical Martian storm. And this research confirms that a lot of these high-velocity surface winds generally create enough stress to lift all of the dust and to move all of the sand grains for many weeks, which essentially proves that the Martian atmosphere and Martian weather conditions are way more dynamic than we previously believed, but naturally also making Mars a little bit more unpredictable and just a little bit more dangerous. Even though these winds are not strong enough to, for example, topple a human structure, as we've learned from previous missions, they're usually long enough and powerful enough to completely cover these solar panels with a lot of dust on the surface, which usually means that you cannot produce any more energy. But obviously this is just the first such study, and we'll probably learn more about the Martian dust devils in the next few years. And then we have some studies on the ultimate question that's still difficult to answer. So what happened to all of the water? Especially since we know Mars had a lot of water in the past, and there seem to be signs of ancient oceans and rivers all over the place. And while right now some of the clues have been discovered in the crater ice deposits in certain locations on Mars. And that's because some of the layers of ice inside these craters act as a kind of an archive, with some of them showing us that Mars went through repeated ice ages driven by the changes in the Martian axial tilt, also known as obliquity. But unlike Earth, whose obliquity is usually stabilized by the moon that orbits around the planet, Mars's obliquity or Martian tilt can swing quite dramatically, which then ends up redistributing a lot of ice on the planet from one location to the other. But with every cycle, the amount of ice seems to have decreased. And so Mars has been actually slowly drying out for hundreds of millions of years, with water slowly disappearing over time. As a matter of fact, some of the ice cycles between 650 and 90 million years ago seem to show direct signs of a lot of ice completely disappearing, suggesting that even 600 million years ago, Mars contained a lot more water on the surface, even though it was mostly frozen. And while some of this water potentially got trapped inside Mars in various minerals and various clays, because Mars does not recycle its water like planet Earth. And though some of the polar ice water is still trapped inside these craters, and is obviously still visible even today, quite a lot of it is probably underground and trapped in minerals, and quite a lot of it escaped into outer space. And finally, we have another unusual study that officially confirms that the time on Mars runs just a little bit faster. Okay, let me explain this. This is all basically the consequence of the Einsteinian time dilation. Since Mars contains less mass than Earth and has a weaker gravitational field, it also produces just a little bit less time dilation, which means that the clocks on Mars tick at a slightly different rate, specifically about 477 microseconds faster per day. And though this is obviously nothing when it comes to the human scale, because that's less than a millisecond per day, this does become critical for a lot of modern technologies, including various satellite technologies, and especially future navigation systems that require coordination with the deep space network that relies on extreme precision. And so extremely recently, researchers finally calculated the exact time dilation difference, but also discovered that it seems to be not constant. Because Mars has an eccentric orbit, this rate actually varies by approximately 266 microseconds per day and makes the overall time measurements just a little bit trickier on this planet. But by establishing these precise timekeeping standards for Mars, we're basically getting ready for interplanetary communication and navigation, which require this precision in order not to make a mistake, especially if we're going to have both human missions and autonomous missions, where timekeeping is crucial. And in contrast, the same team has also discovered that the time on the Moon seems to run just a little bit slower than Mars, specifically 56 microseconds faster per day than on Earth, but over 400 microseconds slower than Mars. And so even though you're not going to be aging faster on Mars, when it comes to timekeeping, the clocks are going to be moving just a little bit faster. And last but not least, we have this somewhat negative news that you might have heard already. This mission that studied Martian atmosphere for so long, the Maven mission, has now been officially confirmed to be lost. After losing signal in December of 2025, it looks like the probe is now in its safe mode and began tumbling wildly and draining its batteries. And because NASA was unable to establish communication, after more than 11 years of research, this mission is officially now over. But the overall scientific exploration of Mars is only beginning, which means that we'll be coming back and discussing more discoveries in some of the future videos once there are some additional updates. And that's because Mars is now not just some kind of an unusual destination, but it's now officially become a natural laboratory in helping us understand how the solar system evolved, but in also helping us understand how life potentially forms on other objects. And it's most likely this planet that's most likely going to answer the ultimate question in astrobiology: are we alone? Or basically the question of if alien life actually exists. But at least for now, that's all we have. Check out previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.